Hey folks, it's Andrew Kilpatrick here, and welcome to part 7 of my tutorial about MIDI. This is going to be the final part of the sort of core series, and if I get questions or I want to go into some more specific details on some other issues, then I'll make some future videos about that. In this part, we're going to round out sort of the basic MIDI spec, talking about a few more system common messages and system real-time messages, and then we're going to talk about the biggest issue, the biggest topic, which is SYSEX. So let's have a look at the points and then let's get right into it. So I'm calling this SYSEX, etc. There's a few other messages that we're going to talk about that didn't really fit into the other sections. And then we're going to talk about SYSEX. So song select and active sensing are two important messages. And then we're going to talk about MIDI manufacturer association IDs and SYSEX messages themselves. So let's go over to the bench and get started. Okay, so let's get the other ones out of the way first, the song select and active sensing, and just quickly talk about what those are. And then we'll spend most of the time on SYSEX. So in the previous video, we talked about using the song position pointer, MIDI clock messages and things to control another sequencer or drum machine or something from sort of a master sequencer. Song select sort of goes along with that in that it lets one sequencer ask the other one to load a specific song. So let's say you had a show that you're doing, let's say you're a one-man band, and you're using some MIDI sequencing to produce some of the backing tracks. A song select message would be something that you could sort of use to automate causing all your devices to load the correct song. Now, there's two situations that I can think of that would be useful for this. The first situation would be, let's say the master sequencer is controlling some other devices like drum machines or other sequencers that have more specific functions. It could send a message at the beginning of a song or when you load a song to say you want the drum machine to also call up that song so that has all the correct patterns and everything loaded in. That's one way. Another way, and I think this is probably the more common way nowadays, is to use this almost like a remote control message. Let's say you're only using one sequencer, but you want to be able to quickly switch between different songs in your sequencer while you're on stage, let's say. So you could use some sort of a controller that you can program what it sends when you press various buttons to send song select messages to quickly, so instead of having to use a mouse and go into menus and things, you could just have it call up from a list of a sort of pre-programmed list of songs. So the song select message consists of 2 bytes. There's the F3, which means song select. That's system common, which means it doesn't have a channel number or anything associated with it. And then there's 1 data byte, which is the song number. So you can have up to 128 songs. And most systems, I think, that would do this would have some kind of a master list that you can set what those songs are, so they correspond to particular files on your drive or whatever. Now, when you use the song select message, let's say you're implementing a system that does this. Let's say you send a song select message. You can't just assume that immediately the other device will be ready to go, because even in modern systems, there's file systems, has to load data off a disk, and there's, those kinds of operations aren't immediate. Even on, the latest, flash-based things, there's still time taken for the file system, go find the file and open it and read in the data and figure out if it's correct and all that sort of stuff. So when you send the song select message, there's an assumption that you should wait, and I forget exactly the amount of time it says in the MIDI spec, but there's an amount of time that you should expect that it will take before the sequencer on the other end is ready to go. So that's song select. I'm not sure how much it's used in modern setups, but it's it's useful. It lets you sort of remote control choosing between songs. So that's cool. Active sensing is something that's probably less useful for the end user and more useful for implementers of software or hardware. I use active sensing all the time. I know some manufacturers use it, even in production products. They send various messages using active sensing and things like that. They just send it repeatedly. So what active sensing is kind of like a heartbeat. So think of it like a ping. Let's say if you're familiar with like network terminology and stuff like that. This doesn't expect a reply, unlike a ping. This is just like the one-way sort of, I'm sending a message saying I'm alive. It doesn't carry any other information with it. The timing of the actual events is arbitrary and doesn't really mean anything. I've seen some MIDI interfaces. I think one of the Roland interfaces that I have just sends it, and it doesn't even blink the light actually, showing that it's sending it. I used to have a piano, Yamaha piano, that would just send it actually quite a lot. It would send it really fast all the time. And I don't know what those manufacturers are using it for, but I can think of a couple situations. One is, let's say you've got a VST plugin or some kind of other software that is doing a two-way communication with the device. Maybe it like lets you set up the presets inside the device. You might want to detect if the device is actually plugged in or not. Now, active sensing doesn't carry with it any information, so you wouldn't really know if it's your device or someone else's, but it's probably a pretty good way to figure out, like, are the MIDI ports opened and connected properly. So that's one way. Another thing, and I use it for this all the time in development, is I actually have in most of my programs, I have a define that I can turn on that lets it just send active sensing. It doesn't send it that often, maybe a couple times per second. And this is a really good way. Let's say you're using debugging and you send debugging information over MIDI, and this is pretty common if you've already got a MIDI port on your device that you're building. Sending debugging information over MIDI makes sense. But the problem is, and this is a case in most modern operating systems that I know of, is that especially with USB, for instance, if your device has a USB MIDI port directly on it, when you update the firmware on your device, even if the MIDI ports were opened by a program, the device obviously will leave and come back on the USB because it rebooted, and the operating system will pick it up and say, okay, here it is, here's your address and so on. But software that was already using the port before it disappeared, and you may have noticed this with other devices, if you plug and unplug a device and the software doesn't detect, let's say the music software doesn't have a way to detect whether the device went away or not, unless it's talking to the operating system at a lower level. Just having the port open, it will appear that nothing happened, except that data will stop transferring back and forth between the device. So I use this message all the time to just basically say, hey, I'm here. If I reboot my device, I have special software that I use for debugging that detects that these active sensing messages stopped, and then it can close and reopen the port. So it's really good for debugging. It's a good sort of sanity check to make sure that something's happening on your device. And that brings us to the major topic of this video, which is SYSEX. So SYSEX stands for System Exclusive. There's other short forms that you might see, but SYSEX is probably the most common one. If you see a file that contains a SYSEX data stream or data packet, it's probably in a .SYX format. I've seen that used quite a lot. And SYSEX is basically the way that the MIDI people figured out how to let manufacturers send any data that they want. Now, system exclusive means it's exclusive to a particular manufacturer. There are some sort of, I would call them like global SYSEX messages that are defined by the MIDI specs themselves. And those are still sort of sent like SYSEX messages, except they don't have the manufacturer ID, that it works a little differently. But for the most part, most people are using this kind of thing to send manufacturer or like product-specific information to a device. So let's say two examples that I can think of that I've used it for, and one we'll talk about. One is firmware updates. A lot of devices, from a lot of manufacturers use MIDI to update the firmware on the device. And they would do that via a SYSEX message, because that means that they can blast a whole bunch of data to a device, and other devices, if they happen to be connected by accident or you've got the wrong port selected or something like that, they would be, or they're supposed to be, unaffected by that data being received, because the device doesn't have to read very many bytes into the message to realize that it doesn't care about any of the other data. It's not destined for it. Another use case, which is more of like an online sort of use case that you'd use while you're using your device, would be to send all kinds of data to it. For instance, patch banks and settings that are custom to a device. So let's say you have a program on the computer that wants to send custom information to the device to update some parameters. And I actually have a program that does this for one of my Eurorack modules. And it basically allows you to send custom presets to the device while the device is running. And other devices are unaware, they don't care. And and there's another example we'll look at here. So that's basically how it works. It starts with F0. So this is F0. This means the start of a SYSEX message. And then F7 is how you end a SYSEX message, and it's called end of exclusive, or EOX if you look at the spec. Anything in between here is the actual SYSEX message. Now, they can only contain 7-bit data, just like all the other MIDI messages that we've looked at. So there's no MSB set. So this is kind of a pain if you want to send binary data. For instance, if you want to send like firmware updates, obviously the bytes in your firmware probably use all 8 bits, not just 7. So people have come up with all kinds of different schemes for how to represent 8 bits over 7-bit data. I've done different ways. You can have it so that you pack the data and you rotate around and fill all the 7 bits with as many bytes as, with all the bits of the byte, and then move over one. I've done other methods where I just use the lower 4 bits and send a byte over 2 bytes on the wire. That's a little less efficient, but it doesn't really matter in some cases. So there's all kinds of different ways that you can decide how to send the data that you care about. The other way is you can just encode your data that you want to send in a format that will just fit directly on the wire without any funny encoding. So we start with a F0, then what we need is the MIDI manufacturer's ID. And if you go to MIDI.org, the MIDI Manufacturers Association maintains a list of manufacturer IDs, and these cost money. You have to pay them every year. It's about $200, and it doesn't really get you anything. All it gets you is, if you stop paying, they sort of shame you publicly by saying that you haven't paid and then encourage you to pay. So it's kind of like you're supporting their efforts in promoting MIDI and so on like that by registering your device ID. Obviously, your devices, if you're building hardware or even releasing software, that's not going to go away if you stop paying. But I pay every year. It's a good idea just to support what they're doing. They try to promote MIDI and all the cool things that you can do with it. So I think that's cool. So you go to them and you say, I'd like to have my manufacturer ID, and they will say, okay, you can pay us money, and then we will give you a number that you can use, and that's your exclusive ID. So you can make any messages that you want within that, and that's just for your use. So at the beginning, they just use single byte IDs, and a lot of the older manufacturers have these ones. I know Dave Smith, who is one of the inventors of MIDI, has ID1, which I think is pretty cool. But as time went on, they ran out of those, of course, and then they had to move to 3-byte IDs. So if the first byte starts with a 0, that means that it's an extended 3-byte ID, and then the next 2 digits are 2 bytes are the ones that are actually for the manufacturer. So in my case, I'm 0172, And so if the SYSEX message starts with F0000172, people can say, oh, it's a Kilpatrick audio message, and they can then ignore it if they don't know what that is. Then after that, between the MIDI manufacturer ID and the final F7, you can pretty much send whatever data you want, as long as it's 7 bits, of course. So here below I've printed out, this is from one of my modules. This is a MIDI interface that's part of one of my Kilpatrick format modules. And this is a setup command that will allow you to configure the outputs on the MIDI to CV converter. So here's the list of bytes that get sent to do this, and then here are the meanings of the various bytes. So let's just go through it real quick, and then you can get a sense of how you might use this. So F0, that's the start of the SYSEX message. Here are the 3 bytes that define my particular MIDI manufacturer ID. And you can go online, by the way. If you go to MIDI.org, there's a list there that you can see all the IDs that have ever been assigned. It includes ones, now they don't seem to reuse them, so it even includes IDs for companies that have gone out of business or have been merged or whatever. So you can see there's it's an interesting sort of historical trail. They seem to assign them in order, so you can kind of see, how old a company is, which is kind of interesting to sort of see the history of MIDI products. Then I use the next byte is always a unique byte that defines the device type. So this particular device type, oh, I've actually even noticed a typo here. This was called something else before. It should be just called K1. This is just from internal documentation. So 4.3 happens to be the device type for this particular device. And then I have usually another byte that defines a particular command, let's say. So this part gets down to the device level. So you can say, okay, I'm this manufacturer, this is the device I want to talk to. Now this is for the particular command that we're sending. So 02 sets the system configuration. And there's not very much in this system particularly. It has 2 CV outputs that are also paired up with gates, and it has various ways you can assign the voice modes and so on. So, this byte says what is the CV1 output doing. It's not doing anything. It's assigned to notes. It's assigned to CCs, or it's assigned to a pitch bend. And same for channel 2. And then you can set a channel number. You can set a value. Now this depends on what you're doing. So if this is a note, this would send nothing. If it's a CC, this would send what CC number it should listen to, and so on. And bend, I think it sets which direction it goes, stuff like that. And then I have these various other modes which are sent. And notice I've only used small numbers. So these are basically all just fitting directly within the 7-bit data that I'm allowed to send here. And most of the products that I've done that have various kind of internal commands that are internal settings, most of them I have something like this, which is usually documented in the manual. Sometimes it's a little too complicated to explain. Like, for instance, I have a module where you can upload custom patterns and things like that. And that one I have a software, but usually you would either publish this, or if someone were to ask you saying, hey, I want to make something that uses this kind of, that controls these functions, then normally the manufacturer would tell you how it works. Some manufacturers don't actually, and so then people reverse engineer it. I know a lot of DJ controllers are like that, and people have reverse engineered them to work with other software, which I think is cool. And so that's basically how it works. So I hope that shed some light on how SYSEX works, and please leave some comments if you have extra questions, and I'll try to answer them. So this kind of rounds out the MIDI series, let's say, of the 7 kind of parts that I was planning on doing. And if you have specific questions, I know some people have asked me about USB MIDI, which I've had some experience with. I may make a separate video about that. But anyway, I hope that this video was helpful, and if you like it, please subscribe to my channel and leave some comments below. Thanks a lot.